Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many top 3 students can be made from a list of 12 students? Now, take note, we have a similar problem with this, but it talks about how many first to third rankings can be made from a list of 12 students. In that specific situation, please review that video. We used permutations because the first to third ranking is different if we're going to interchange the students. Say for example, student A, B, and C. Once A is our first, second is our B, third is our C. But if you're going to interchange student A and B for the first and second positions, that's a different ranking. This time, we're just talking about how many top 3 students with no specification of the ranks. This problem is talking about combination, because for combination, we do not deal so much with arrangement. Say for example, the top 3 students are student A, B, and C with no specific order. If you're going to announce student B, C, and A, or student A, C, and B, they are just the same top 3 students. Hence, those top 3 is just counted as one. But for permutation, we'll be counting them differently. Again, this problem is all about combination. The formula for combination is in this manner: N, C, R. Similar to the formula for our permutation, N, P, R. And probably I would like to show a little bit difference when you talk about the solution between the two. But this time again, we'll be using here top 3 students, in short, combination. Our N would be 12 students. We have 12 students. And for our, what do you call this one, our R, that would mean we only have 3 students taken at a time. So for our combination, the formula is this one here: N factorial over, you will have N minus R factorial times R factorial. This is different from the formula of our permutation, which is N factorial over just the result of N minus R factorial. We don't have this expression here. So by simply plugging in the values, our N here is 12 factorial to be divided by, you have 12 minus 3 factorial, and you will have your times your R, which is a 3 factorial. So you would see a formula here which is expressed in this manner: 12 factorial over 12 minus 3 is 9 factorial times 3 factorial. You would know that your process is correct if you're going to add the numerical expressions 9 and 3 will result to 12. I'm not talking about adding of the factorial notations, just the numerical expression 9 and 3, which is 12. We all know that our n factorial, in that case 12, 9, and 3, can be expressed as the product of n, or 1 to n integers. So n in reverse order, we have n times n minus 1 times n minus 2 until you reach 1. This case, you will have 12 times 10 times, times 11 times 10. And let me just end at 9 factorial. No need to worry about that. Of course, you can rewrite this as 9, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I just stopped there because I already have 9 factorial on my denominator. Because if I will extend this to 1, I will need to extend this to 1 as well. Why not stop there so that I could cancel these 2? And of course, I still have 3 factorial here. Okay, so after that, we know that 3 factorial is actually 3 times 2 times 1, which is equal to 6. I'll be using this 6 because I have 12 here. Once I will divide 6 and 12, in short, all of this, I will still have 2 here. And leaving my entire denominator simply as equal to 1. At this time, even without the use of calculators, I can just easily have an expression which is non-fraction. So I simply have to multiply 2, 11, and 10. No need to have the lengthy process. That's the answer. 2 times 11 times 10. I have here 220 possible top 3 from a list of 12 students. This is the number of combinations for this problem. If we're going to go back to the similar situation where we talk about simply arrangements, again, permutation, we are expecting a higher number than this, and you can review the previous video of that. You will have 12 factorial here to be divided by simply 9 factorial. And since 12 can be expressed as 12 times 10, times 11 times 10 times your 9 factorial. Again, I'm just showing the difference between the two. Then you have your 9 factorial on the denominator, which you can cancel. The total number of ranking from first to third is the product of 12 times 11 times 10. So we were expecting 1,320 different rankings from first to third, because again, that was on permutation. Look at the difference between the two. We are expecting that our answer for combination is, the total number of combinations is lower than the permutation. Again, this was covered with the previous video. You might want to review on that, on the number of first to third rankings on the same list of 12 students. But for this specific item, for the number of top 3 students possibilities from the same list of 12 students, you have 220. And that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.